Well, guys, thank you so very much for being here today. My name is Eric Kurtz, and I am so thrilled to be joined today by Dawn. And Dawn is going to be talking about Math Whiteboard. I came across this, Dawn, about a week ago, would you say? Is that when we first connected?
Yep, just about a week ago. Yeah.
All right. I had seen a video. I believe it was through NCCE. Does that sound right? Maybe a conference you had done a presentation for. Does that sound right?
I think that's correct. Yes. I believe
Excellent.
that's where you learned about us.
Yeah. And I, as a technology support person, technology integration person, and my day job, I'm always keeping my eye out for things that are useful to pass along to the teachers that I support. And wow, when I saw what we're going to be sharing today, it really blew my mind. Checked all the boxes. A free tool that is easy to use and powerful for teaching and learning, engaging for students. So what we're going to do here today, folks, is I'm going to, for the most part, just be playing as host. I'm going to turn this over to Don, let him introduce himself, and allow him to share his screen and demonstrate this amazing product, Math Whiteboard. While Don's doing that, I'm going to do my best job to keep an eye on the chat. So if you guys have questions, comments, anything that you would like to ask, please throw those into the YouTube chat. I'm going to keep an eye on that and pass those over to Dawn as the session proceeds here today. Other than that, I'm going to go ahead and turn this over to you, Dawn, and I'll let you give a quick introduction and share your screen, and away you go.
Awesome. Eric, thank you so much for inviting me today to chat with everyone. It's a great pleasure. I happen to be in Boston right now, so you'll notice I have the windows open, and sometimes the clouds pass by and it's very bright out. It's not so bright, and then sometimes the sun is shining. So we're having a great day here in Boston. It's about 75 degrees, so I'm pretty excited about the day, and we're pulling into summertime, which is pretty nice. So I'm Don Carney. I happen to be the CEO and one of the founders of a company that makes a product called Math Whiteboard. It has its origins in some PhD thesis work that was done at Brown University. That's where I did my PhD in computer science, and my team, we all did our graduate work in the computer science department at Brown, and the work stems from research that was done in a research lab that focused on user interface technology and educational technology. And I'm really excited to show you what it's all about. It's been just a few weeks since we launched this Math Whiteboard product, and we're pretty excited about it. It's a totally free tool. It's a website, mathwhiteboard.com, that you go to. It's totally free, and it's also barrier free, which means there are no accounts, there are no passwords, there's no logins, no subscriptions, just a website you can go and use. So let me jump in and show you what Math Whiteboard is all about. I'm going to share my screen. And let's see. Oh, there's my PowerPoint slide. We believe that Math Whiteboard is, I'm going to show you one PowerPoint slide, and that's it. It'll be up for just a moment. We believe that Math Whiteboard is the very first collaborative whiteboard designed specifically for mathematics teaching and learning. And if you want to reach out to us, you can reach out to us on our Twitter account at Math Whiteboard. You can also visit our website at mathwhiteboard.com. And that's me. I'm Don. So let me jump in and give you the tour of Math Whiteboard. You'll notice that I have two web browser windows up on the screen here at the same time. That's because I want to show you eventually the interaction that users can have. Maybe it's a teacher and a student in sharing this collaborative Math Whiteboard synchronously or in real time. But to start with, let me just jump in and show you what the Math Whiteboard system is all about. So I'm going to start a Math Whiteboard, and I'm going to click on New Math Whiteboard. And again, this is a website. I'm at mathwhiteboard.com. And just before I get started, a couple of things to mention. I happen to be using a Windows tablet, and I'll be writing on the screen with a stylus quite a bit during this demonstration. But everything I'm doing with the stylus and writing on the screen, I can also do with a keyboard and a mouse. And I'll show you the keyboard and mouse interface in just a little bit. And even though I'm using a Windows device, this is running in a browser, so it can run everywhere. It can run on a Windows machine, it can run on a Chromebook, an iPad, a MacBook. It just runs on every device because it runs in a browser. And again, you can use a keyboard and a mouse to use Math Whiteboard just as effectively as with a stylus. But let me show you what Math Whiteboard is all about. Now, I'm going to turn off my webcam because as I'm using Math Whiteboard, my face tends to get really close to the camera and the screen. So you may not want to see that. So let me just turn off my camera really quickly here. There we go. And so I'm going to jump in and show you what Math Whiteboard is. So think of Math Whiteboard as a smart piece of math paper. For example, I can write some math, 1 plus 2. That's pretty simple math, but you'll see it recognizes what I write, and I can get an answer. 1 plus 2 is, whoops, I want to change. I just write a little arrow here, and I can get an answer. 1 plus 2 is 3. I can change the math. I can change that 1 to a 2, and the answer will update dynamically. Or I can make this 2 an A, and then I can assign a value to A. So when A is equal to 1, A plus 2 is 3. I can change the value assigned to A to a 2, and the answer will update dynamically. A plus 2, when A is equal to 2, is 4. I can change this 2 over here to a B, and then I can assign a value to B. So when I assign the value of 3 to B, we can see the answer A plus B updating dynamically. I can write more math on the page, maybe A minus B, or A times B, or possibly A over B, and I can get answers for all of these expressions as well. Oops, I'm going to rewrite that arrow. Now, underneath the hood, we have a very powerful computer algebra system that allows me to do some very simple numeric arithmetic, like you've seen me do so far, and some early algebraic arithmetic. I can also do some more advanced mathematics. For example, we can do a definite integral and get a solution as well. Oops, I want that A to be an A. You'll notice that every once in a while, I make a mistake here in my handwriting, or the recognizer misrecognizes what I write. It's very simple to just scribble out what I've written and rewrite it. So now when I go back and I change the value assigned to A from a 2 to a 6, we can see all of the answers on the page updating dynamically. Or if I change 3 assigned to B to maybe a 4, we can see again all of the answers on the page updating dynamically. I can even assign to A an expression like x plus 1. And now x plus 1 substitutes for A across the page. So learning math is about seeing connections between things. Here, we're looking at the relationship between A and B with respect to some operators, like plus, minus, divide, and so forth. In algebra-oriented topics, we look to see connections between other types of things, like algebraic expressions and graphs and tables and so forth. Here's a math expression that we're all familiar with from our algebra classes in high school, the slope-intercept form of a line equation, y equals mx plus b. I've written it on the page. The system recognized what I wrote, and with a simple gesture, just a stroke of my pen, I can create a graph. I'll do that again. So with a stroke of my pen, I can create a graph. Now I can pinch and zoom with my fingers the graph. Now, if you happen to be a math person, you may notice that we have selected default values for m and b of 1. That's because the graph has a slope of 1 and the graph has a y-intercept of 1, but I can change that. I can make m equal to a different value, maybe 2. And now you can see the graph updating dynamically. So now the graph over here has a slope of 2. I can change that again to a different value, like 3, and the graph will update dynamically. I can be more interactive by creating a slider for m, just by drawing a straight line down from the equal sign of that assignment. And now I have this dynamic control that allows me to show very visually what m, or slope, really represents. What is slope? That slope. When slope is negative, it looks like this. When slope is positive, it looks like that. B is the y-intercept. I'm going to create a slider for B. The way you create a slider in Math Whiteboard is when you have an assignment on the page like this, B equals 1, or a variable equals to a number, just draw a straight line down from the equal sign like that, and you can get a slider. And now the slider is a dynamic control that interactively changes the value of assigned to the parameter, in this case B. But now looking at the graph, as I change the value of B, I'm not exactly sure what B is doing. What is B doing? Well, B is this value. If we look at this point here, 0, B, and we graph it, now we can really see what B is. It's that point where the red line passes through the y-axis. And when I change the value of B, we can really see what B represents. It's the y-intercept. So there's something I say often, and I think it's really important. Learning math is about seeing connections between things. Here, we're looking at the relationship between an algebraic expression and a graph. You know, often in the math classroom, the math teacher, the math student, works in the primary workspace. That's paper and pencil. And that's where we do all of our work in mathematics, with a pencil on a piece of paper. And we use complementary workspaces like a graphing calculator or a computer to look at graphs and tables and solutions and diagrams and animations. All of a sudden, we've got these multiple workspaces, and they're all disconnected. And they're far from each other, not just physically, but cognitively. So what we try to do with Math Whiteboard is bring all of these mathematical representations together in one workspace, allow the user to move very fluidly between the representations, and hide all the technical stuff behind the scenes. So let me show you another example that really demonstrates this concept in a very powerful way. The concept is, having multiple representations in one workspace. So we're going to take a look at a related rates problem. I'm going to draw a couple of cars on the screen here. So we'll take a look at a couple of cars. Yep, those are cars. I'm not an artist. This is car A, and this is car B. And we'll give length to the road. We'll say the road has 1,000 units in length. And I'll write two expressions over here that represent the motion of the cars. So we'll say that car A has a constant velocity of 80 units of distance per unit time. That's a linear function. It says the location of car A along the x-axis is defined by 80 units of distance per unit time. Car A is going 80 miles an hour. Car B is a police car that has to accelerate to catch car A. So in Math Whiteboard, we have this ability to connect hand-drawn sketches with handwritten mathematics. It's called math sketching. Under the More menu, I can turn on math sketching. And now this little slider pops up. And on the right-hand side of the slider are these little player controls. When I press the play button, we can see the cars moving across the screen in an animated simulation as described by the math I just wrote on the page. Pretty cool if you ask me, and probably pretty cool for you as you're watching. But imagine, we are adults and we think this is cool. Imagine what happens when you show this to kids in the classroom. Their heads explode. They start asking really great questions that require knowing more math in order to answer the question. For example, can you please make the car go faster? Or can you make the car bump up and down? All of a sudden, great questions that require students to know more math. Now, of course, from a very high level pedagogical perspective, what we're doing here is we're making a connection or a relationship between this very abstract algebraic notation that we see on the left-hand side here and a very concrete example that we see on the right. When you're learning math, it's really important to be able to make connections between the abstract and the concrete, because often you want to answer the question, why am I learning this? Who cares about what I'm learning? When will I ever use this again? In algebra, that happens a lot to students. They try to figure out why they're learning this, and being able to draw connections between the abstract that they're learning in the classroom and the real world that they see outside, like cars driving along the street, is really important for the learning process. Now, that was a high level abstract perspective on this. There's also a very practical aspect to this, and this is a related rates problem, and related rates problems show up on standardized exams all the time, especially in algebra. And when we're looking at related rates problems, we're typically asking a couple of questions, especially in the algebra areas. And the questions are, at what point in time does something happen, or at what point in distance does something happen? Here the question is, when does car B overtake car A? And we can see that happens right about there. Well, that was a math observation, not a math answer. We want to get the math answer. How do we get the math answer? There's a couple of different ways to do that. We could set the equations equal to each other and solve. And of course, Math Whiteboard has a very powerful computer algebra system underneath the hood, and I could do that right within Math Whiteboard. But the way I really like to solve this is through exploration. This is kind of like the scientific method. What we'll do is we'll draw a hypothesis, test the hypothesis, and then prove it. So let's do that. We're going to graph these two functions here. And then I am going to pinch and zoom the graph. And we can look at the graph. And now, of course, this is a system of equations. And when you're in math class and you see a system of equations, typically we're looking for, in the graph, we're looking for intersection points between the two equations. And we can see those pretty clearly here in the graph. There's a point of intersection at the origin. That's when the cars start. There's also a point of intersection out here in the quadrant. That's when the quadratic or the parabola overtakes the linear. When the blue curve there overtakes the red line, that's the point at which we will hypothesize that car B overtakes car A. And we can see in the graph that looks like it happens at about time equals to 8 and distance equals to about 650. Right, so that's our hypothesis. When time equals 8, the car should be at the same spot, and that spot should be about 650 units of distance along the road. So let's test the hypothesis by running the simulation for 8 seconds. So I'm going to bring the slider over here. I'm going to drag the slider over to 8 seconds, and we'll see if the cars are at about the same spot. It looks like they are, but you know what? We're just eyeballing the simulation. We're eyeballing the graph, but we know we're on the right track because the cars look like they're at about the same spot. Let's prove it. The way we prove things in algebra is through substitution. So I will substitute the value of our hypothesis when time equals 8 into these equations, and we'll see what happens. When time equals 8, what is the value of a sub x? What's the location of car A along the x-axis? We think from the graph it should be about 650 units of distance. Let's see. 640, pretty close. If b sub x is also 640, we have proven the hypothesis. Awesome. So I love this example because it demonstrates the power of having multiple representations in one workspace, and everything is connected. You know, you've got the algebraic representation, you've got a solution, you've got a simulation, you've got a graph. You could look at a table of values, and everything is connected. So when the student said, can you make the car go faster? Well, we can just change the 80 miles an hour to 90 miles an hour. And, oops, I want that to be 90 miles an hour. There we go. And look, all of a sudden, you know, the graph changed. The point of intersection moved over here. The solutions changed. If I ran the simulation again, the accelerating car wouldn't quite catch up as quickly. So I'm going to pause for a moment. There are still some things I'd like to show you, but let me pause for a moment and see if there are any comments or questions.
Absolutely. Wow. Well, first of all, this is phenomenal. Like I said, I started off my career as a math teacher. I've been in education for 29 years, but my first 7 years were as a middle school math teacher. So there's always a very special place in my heart for anything math related. And so when I saw this the first time, I was absolutely thrilled by the way this is not just a tool to represent math, but to explore math, to ask the what if questions, because that's where, when you notice patterns and connections and you see, and you draw conclusions from that, that inquiry-based learning is so powerful. So I just want to say, love it, love it, love it. And looking at the comments, we're getting a lot of wows. This is very cool. This is awesome. Yes, there are questions coming in though, and I certainly want to relay some of those over to you. I know you've got more examples to show here, but I think we'll go ahead and address a couple of quick questions that folks are having.
Great.
One of the things that people have asked about is there an easy way to see a list of all of the cuts that you're using? Like we noticed when you did the little swoop, it made the graph. When you pulled down, it made the slider. I've investigated the help menu, and I'm betting, would that be a good place for them to go? Because it seemed like that was a pretty detailed tutorial in the help menu to see those.
Yeah, there's a couple places to go. So I'm just going to start a new whiteboard here just to show you clearly. Under the help menu, you can just click on the help menu and it will bring up a tutorial. It's a pretty brief tutorial, but it covers all of the key functionalities to get started and to become a master of Math Whiteboard. There's also, when folks start a new Math Whiteboard, when I click New Math Whiteboard, you get this little pop-up that shows the bits of functionality that are really key in order to get started with Math Whiteboard. But most folks, when you start Math Whiteboard, you dismiss that pretty quickly, and then you jump in and you start using it, and then you say, where did that pop-up go? Well, we've got the pop-up right here. So if you click this button at in the upper right-hand corner, and you just click Getting Started Pop-up, it'll show the pop-up again, and it'll walk you through things like, the scribble erase gesture, for example, is in one of these pop-ups. Pretty simple thing, and the gesture to graph equations is there, and the slider gesture, and so forth.
That is fantastic. Yeah, that is great to have those right there at your fingertips when you need those. Another question that has popped up, and I know you've mentioned this, that this is a free tool, but I understand as educators, there's always that little bit of a fear in the back of your mind that yeah, free like with an asterisk after it, or free and then it's not free and it goes away. And I mean, I understand that your company does produce other products that actually help you keep a roof over your head, and that this is a product that you have committed to being a free tool for schools to use. But I'd love for you to address that for those people that are understandably curious about seeing such a wonderful, powerful tool and going, no, 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 this isn't really free, is it?
That's the catch, right?
Yeah.
There's no catch. It's a free tool, and our company has been around for a little bit more than a decade. So we've been in the business for a while, and we sell another product. It's called Fluid Math, and that is something that we charge subscriptions for, and we sell that. And we're very fortunate to be able to provide this tool as a free tool for teachers and students and users. And I guess, you can kind of think of us doing it in the opposite direction of a lot of other companies out there. A lot of other companies will go out and before they launch their product for sale, they'll launch it as a free product, and then start, as soon as they get a lot of users, they will then start charging subscriptions for it. We kind of took the opposite approach. We have a system that we've been selling for a little bit more than 10 years. And this Math Whiteboard is actually a part of the Fluid Math system. So if you had a Fluid Math subscription, you'd already have Math Whiteboard. The Math Whiteboard is a system that has accounts and subscriptions and logins and so forth, and it kind of layers that on top of Math Whiteboard with additional functionality. But the plan for us with Math Whiteboard is to leave it free.
That is fantastic. And we'll get to some more examples here in just a minute. I know I've seen what's coming, so I know there's some really cool stuff still to take a look at here. But there was another question, understandably, folks asking about COPPA and FERPA compliance, things like that. I understand this tool does not have a login. It's not collecting information. So I assume we're all good to go there, but I certainly want you to be able to address that yourself.
Yes, great question again. And it aligns really nicely with FERPA and COPPA just because of what you said. There are no logins, there's no passwords, there are no accounts. We don't collect any personally identifiable information. So from that perspective, we're in pretty good shape.
That is fantastic. I do know that a lot of the examples we've been looking at here today have been a little bit higher level math. We've had a few people asking about, what about lower grades? Are there, applications? I thought right away of the equivalence tool you have might be a good example for something like that. But I don't know, would that be something that you'd like to chat about, how this can be also applied to some of the lower grades rather than some of the higher examples that we've seen so far?
That's a great lead in to another bit of functionality that I'm hoping to share, and I'll share that right now.
Perfect.
We have this ability within Math Whiteboard, and I think it's a very unique functionality that I don't think you'll see anywhere else. We have this ability to look at equivalences across a page and test equivalences and color code those equivalent mathematical expressions in the same color. Let me show you what I mean. So under the More menu, I can turn on Highlight Equivalence. And, oh, you know what I'm going to do? I'm going to turn off my camera again because my face is going to start getting really close to the screen. So we have this ability to connect equivalences on the page. What do I mean by that? When I write the number 3 and the number 2 on the page, obviously not equivalent numbers, and they're color-coded differently. And the number 4 is not equivalent to 2 or 3. So again, it is color-coded differently. But the number 6 over 3 is equivalent to 2, so it's color-coded the same as 2. And the number 4 over 2 is equivalent to 2, and again, it's color-coded the same. So really applicable at the lower grade levels where we might be looking at equivalent fractions and decimals and so forth. So for example, I could write some other numbers on the page here. Let me turn off the color coding for just a moment. I'll write some other numbers on the page. Maybe we have 10 over 2, and we have 5.0. and maybe, whoop, I want that to be 0.0, 0.0. And then maybe we have 20 over 4. And 20 over 4, these are all equivalent to each other. But let's mix them up and try to do a little matching game here. So now I don't know, oh man, I don't know which ones are equivalent anymore. So let's try to guess. So maybe the 4 over 10 over 2, well, there's 2 2's there, and the 6 over 3, I don't know, that one, maybe that's equivalent to the 5. And the 4 over 2, maybe these two are equivalent. And then we can turn the highlighting on again. And when we look at highlighting, I didn't do the matching correctly. These numbers are supposed to be together, and these numbers are supposed to be together too. So you can imagine using this at the lower grade levels where we're looking at equivalent fractions and equivalent decimals and so forth. So this is really great for equivalent numbers on a page, but we can also use this for equivalent algebraic expressions on a page. And let me show you how you might do that. So we might take a look at some algebraic identities. So a plus b and b plus a are equivalent, but a minus b and b minus a are not equivalent. So they're color coded differently. And then a times b and b times a are equivalent, but a over b and b over a are not equivalent. So they're color coded differently. This is great for these early algebraic identities, but also applicable at the higher grade levels where we might be looking at things like other types of identities like trigonometric identities. So tangent of theta is not equivalent to sine of theta, right? So they're color coded differently. But sine of theta over cosine of theta is equivalent to tangent of theta. So it's color coded the same. Now these are identities that we're looking at here, but possibly the most powerful way in which to use this color coding is in step-by-step problems. So let me do a couple of step-by-step problems for you here. First, we'll look at an algebra example. So here's 2x plus 3y equals 4. If we were to solve for x here, what would we do? The first thing we might do is move the plus 3y over to the other side. So let's do that. So the first step here might be 2x equals 4, and we're moving plus 3y over to the other side, right? So let's plus 3y. Now, wait a second. It's not the same color as the first step. We know that every step in a step-by-step problem should be algebraically equivalent to any other step. But these aren't color-coded the same, so they must not be equivalent. I must have made a mistake. What did I do? Oh, I forgot to change the sign when I move the plus 3y over, because when you move something across the equal sign, you should change the sign. Let's change this plus to a minus. And now that first step is equivalent to the original statement. So we know that we've done the right calculation for the first step, and we can move on and continue to solve the problem. Of course, what we've done here is we've given immediate feedback to the student, to the user, indicating that, well, they've made a mistake. We didn't tell you what the mistake was, but we've given you that immediate feedback that can help the student with confidence know that they've made a mistake and address the mistake immediately as the mistake happens. Now the student can continue on and solve the problem. So we can say x equals 4 minus 3y over 2. And of course, that's a correct solution, and it's color-coded the same. Now, this example is an algebra-oriented example. These step-by-step problems, of course, occur all throughout mathematics, whether it's at the early grade levels where we're looking at order of operations, or we're at the higher graduate level courses. So let me show you one example that might be an order of operations example. So we'll say 2 minus 3 times 2 minus 3. Okay, if we were to solve this, the first step we might take is this step here, right? We might multiply the 3 across the parentheses. Let's do that. So this would be 2 minus, and then 3 times 2, that's 6, right? So 2 minus 6, and then minus 3 times 3, maybe that's a minus 9, right? Oh, wait a second. Again, the step is not color-coded the same as the original statement. I must have made a mistake. What did I do? Oh, I forgot. I forgot to multiply negative times a negative, which is a 0, which is a positive. So let's make that a positive. Now we can see that the first step is equivalent to the original statement because it's color coded the same. And now I can progress along and continue. So the next step, of course, would be 2 minus, and 6 plus 9, that's 15, right? Oh, wait a second. It's not color coded the same. I must have made a mistake again. Oh, it's minus 6 plus 9. That's a plus 3. Okay, it's color coded the same. Oh, great. And I know what 2 plus 3 is. That's 5. Now, of course, there are multiple ways to solve any math problem. This is one way to solve it. There's another way to solve this, which would be 2 minus 3 times, and then 2 minus 3, that's minus 1, right? This is color coded the same, so I knew I did the first step correctly. And then the next step here should be 2, and then it's 3 times minus 1, so that must be minus 3, right? Oh, wait a second, not color coded the same. I must have made a mistake. Oh, I forgot again to multiply the negatives. So that's a plus 3. And then, of course, down here at the bottom, we have a 5. So, an interesting bit of functionality. I don't think you'll see this anywhere else. And the really valuable thing here, I think, from a pedagogical perspective, is not only that we're giving immediate feedback, but when a student is working through a multi-step problem, maybe it's 5 or 6 or 7 or 8 or 9 steps, and you get to the bottom and you realize I got the wrong answer. It can be very discouraging, especially for students who are struggling with mathematics, to realize, holy cow, I have to go back and do the entire thing again because I don't know where the mistake is. I'm going to start from scratch. What a bummer, because I spent so much time trying to get to the solution and I couldn't solve it. I've got to go back again. Very discouraging for students, especially who are struggling.
Absolutely fantastic.
There's still a few more things I'd like to show, but let me see if there are any other comments. Oh, thank you, Eric.
Yeah. So, and again, I love the use of the equivalencies, to be something that is helping you check every step of the way and reinforcing, those good math concepts. I love that. So yeah, there definitely are still questions coming in. And I know there's some other features we still want to show here. One question that popped up was about applying this into the sciences rather than just math, which certainly makes a lot of sense. But specifically, they were asking, what about chemical equations and being equivalent? I'm assuming you haven't branched out yet into chemical equations and the equivalencies of those.
That is a great question. Chemistry, I've chatted with a couple of chemistry teachers who have explained to me that chemistry is very much like an algebra class because we're always balancing equations in chemistry. Yep. So this equivalence testing within chemistry would be very valuable. Of course, we're always expanding the tool, and we're always advancing, the areas in which it can be used. So our first goal is to expand this across the breadth of K-12 mathematics, and then extend it more broadly across multiple subject areas. So at the moment, no chemistry, right. But stay tuned.
Understandable. One of the really awesome features, and people have been asking about this since we've started here, and I think it's a good time to address it now, is the idea of collaboration. I understand that each whiteboard is getting a unique link, and I have a couple of questions that have come up through the chat related to that. One was, what can you do with that link, and which would lead into the idea of collaborating with somebody else. But then another one just to keep in there also is, how long are the links good for? Like, if I create a whiteboard, does that unique ID eventually expire, or, is it usable for an indefinite period of time? But let's chat about the ability to collaborate, which I think is just so slick.
Yeah, that's a couple of great questions there. I'm just going to turn off my video because I'm going to show you more. But in answer to the first question about the second question, when do these things expire? We just launched this a few weeks ago. So we're kind of testing out the waters for what we think is the right thing to do with the expiration of these math whiteboards. At the moment, they don't expire. And as we move into the future, we may make them expire after a period of non-use. So we found that there are a lot of people kicking the tires and creating math whiteboards and then not going back to them. So it may be that after a week or two or a month or a year, they will just kind of clean out the database and get rid of the Math whiteboards that haven't been used in a long while. But for the moment, if you're using these and you're building a Math whiteboard, and then you hope to use it that day or a week from now, you don't have to worry about it. They're not going to be expiring. Whiteboards that have been created within a short period of time, we expect we won't have them expiring. Now let me show you how you can share and how this Math whiteboard can be shared in real time, collaboratively or synchronously with a student. So every Math whiteboard has a unique URL. You can see that in the URL here in the web browser. When I click on copy link, that gives me a copy into my clipboard of this URL, which I can now paste into my learning management system, Microsoft Teams chat, or Google Classroom, or an email to a student. I'm just going to paste that into this web browser on the left-hand side here. This web browser on the left represents maybe a student on their computer, possibly at home. They could be in the same classroom, in the same room, or at a distance. And these Math whiteboards can be, as I just said, shared synchronously. So when the teacher on the right-hand side writes something on the whiteboard, for example, a pretty simple math expression, it shows up on the student's screen. It doesn't just show up, it's alive, so it's editable because this is a shared collaborative page. So I wrote that on the right-hand side. Now I'm going to edit it on the left-hand side. Right? And all of that math functionality is now available. I can create graphs, I can create sliders, and all the great math functionality. We can use the color coding is there and available for the teacher to use and synchronously communicate with the students. And about a year ago, when the pandemic hit, and every teacher in the world went from almost overnight from teaching in the classroom in a synchronous environment where you're working real time with your students to now an online environment where there's a lot of asynchronous communication. And the synchronous communication is a bit awkward in a math classroom because math is a subject where you have to see the math and have it explained to you at the same time. I cannot just show you the math solution, or I cannot just show you the math. I have to explain it to you at the same time. And likewise, I cannot just explain it to you. I have to show you. That's why, we have in math, we have all these different representations. And the synchronous communication of math online at a distance is really challenging because there are no tools that allow for the synchronous communication of math. There are many whiteboards out there, but none of them are designed specifically for teaching and learning of mathematics, as Math Whiteboard is.
Well, that is wonderful. And I know that the example we're looking at right now, it is the teacher and a student, but there really wouldn't be any limit to that, right? You could have, multiple students using the same link. If I understand, you can even do multiple pages within the whiteboard. Is that correct? So that different students could be working on different portions of it?
Eric, that is a great question, and that's correct. There's no limit to the number of users we can have on a whiteboard. Of course, there's a practical limit, but we don't bound it sort of from a technical perspective. Now, math teachers are very creative, and they've been using a bit of functionality in Math Whiteboard that we weren't expecting to be used this way, but it's pretty cool use of this feature that we have in Math Whiteboard. You see, I've opened up this slide sorter on the left-hand side of the Math Whiteboard on the right-hand side here. And I can add pages. So we just have one page in a whiteboard. If I click the plus button, that will add some more blank pages. Or I can just make a copy. I click on that first page there, I hit Control-C and Control-V a few times, and now I've got a few copies of that page. And what the teachers have been doing that we weren't expecting, but this is really cool usage of this functionality, is they're assigning to each page a different student or a different group of students. So for example, they might put on page 2, group 2, and on page 3, they might have group 3, and on page 4, they might have group 4. So let's say, for example, the student on the left-hand side is in group 3. So we'll highlight the third slide here, and maybe this is two students working together. Maybe Mary and Johnny are working together, and they turn on their green markup pen here and they write some math on the page, right? Now, that was the students writing this on the third page of on the left-hand browser here. The teacher on the right-hand side, you can see right there, can notice that there have been updates to that third slide because you can see the green ink on the page. Now the teacher can watch in real time as the students are doing work. So for example, maybe the students are having a little too much fun and they're drawing, smiley faces on the page. And, the teacher can see in real time that the students are, what the students are doing on each of the pages. So a pretty cool use of this functionality within Math Whiteboard, which allows the user to have multiple pages. So great questions there. Yes.
Yeah.
Awesome.
And something that I'm learning new things the entire time we're doing this as well. When I was playing with this over the last week, one thing that just might be a fun tip to throw out to people is I do notice you jumping between some of the different tools at the top when you draw or write. And so the first button, which is the Math Write button, is different than the third button, which is the drawing button. So like if you want to put those numbers 2, 3, 4 on there to indicate, group 2, group 3, group 4, but you don't want them to be processed and turned into, actionable numbers. That's where the drawing tool comes in versus the math writing tool. Am I following you correctly in that?
Yeah, that's correct. Let me just show you really quickly how these modes work. So we have a couple of different input modes up here on the upper left-hand corner of the menu. There's a draw mode. That's where I draw things like a smiley face. There's the math writing mode where I write math on the page, 1 + 2. And then there's the math typing mode. And with the math typing mode, I can enter math notation with a keyboard. As I mentioned early on, Math Whiteboard can be used on any type of device, whether you have a touch screen or not. And let me show you quickly how the math typing mode works, because it's pretty powerful as well. And everything I've done so far in Math Whiteboard with a stylus, I can also do with typing on the screen. So for example, I might type a couple of math expressions. I'm going to turn off my highlighting of equivalence here. I'm going to type a math expression. So here I'm typing y = ax squared plus bx plus c, right? Now, I've just typed a math expression on the page here with my physical keyboard. I use my physical keyboard to type this, but not everyone knows how to type math with a physical keyboard. So for example, how do you type with your physical keyboard x squared? For me, since I'm familiar with the key sequences, I can hit Shift-6 or get the caret key, and that will give me the superscript. Not everyone knows how to do that. So down below, we have what we call a virtual keyboard. This is the pick and peck keyboard. So I can use my mouse to pick the symbols here. I can say y = x squared. Now we've got these two math expressions on the page. And folks who are just beginning to use Math Whiteboard and have seen me give a demo, sometimes they will try to do the swooping gesture with the math expressions, and that doesn't work. So what you really do is you go to the Insert menu, select Graph, and then that gives you an empty graph on the page. And I can drag and drop these math expressions right into the graph area. And those expressions are plotted. And I can click on A, B, and C, and I've got sliders for A, B, and C, which allow me, again, to dynamically manipulate the parameters, which update the graph. And everything I've done so far with a keyboard and a mouse, everything I've done so far with a stylus or my finger on the screen, I can do just as effectively with a keyboard and a mouse, because sometimes you don't want your big ugly handwriting on the page because maybe you're presenting these to your students and maybe your handwriting doesn't look so good and it takes up a lot of space. But underneath your handwriting, you can convert your handwriting to typeset. Underneath your handwriting is a button. When I click on the button, my handwriting will go away and I'll be left with just the typeset math. So now I have the typeset math on the page. And I can take this typeset math and then I can drag that into the math expression. Now, I may want to plot this in a different plot area. I can just draw a big plus and that'll give me a blank graph on the page as well. And I can drag and drop that math expression into the second graph area. And that there's one B slider over here, but that associates with any B parameter on the entire page. So when I'm changing B over here, you can see all the graphs updating dynamically. But let's get rid of this y equals mx plus b for a moment, because you might be creating these activities or math whiteboards to present to your students. And when you do that, you may want to include some instructions on the page. So we have this text box up here. And when I click on the text box, I can now type some instructions on the page. So I can say, play with the sliders to understand the transformations, right? Something like that. Those are my instructions for the students. But these text boxes are really rich. I can do some pretty powerful things. For example, one of the things I can do is embed a YouTube video. So when I click on edit here and I select insert and media, I can now put the embed code for a YouTube video right into my Math Whiteboard. I happen to have this is a Silicon video, I think, where he's talking about the quadratic equation. And as you know, every YouTube video has a share link or share button. I can just click the share button. That will give me the opportunity to get the embed code. So I can click on embed, and then I can click on copy, and that will copy the embed code into my clipboard. And then I can go back to my Math Whiteboard, paste that into the text box, and all of a sudden I have a YouTube video embedded right into my Math Whiteboard. That's live. It's not like a link that I click and it opens up in a different browser or browser tab. I can play that. And when I play it, it's live on the page. So, again, in the spirit of Math Whiteboard, we want to keep all the representations in one workspace because it's easiest to see the connections between things when they're all in the same workspace.
Well, that is fantastic. I did not know. So I am learning new things as well here as we're going through. That is fantastic. Couple of things. I know we're getting close to the end of the time that we had allotted for today. We kind of set aside an hour for this. Weren't sure if we'd use the whole time, but we certainly want to be respectful of that time and not go beyond that. So I did have a few more questions that had come in. Want to toss those out to you so that folks can get those answers. One of them that has come up twice so far is the question about creating a graph from a table rather than a table from a graph. I've seen you do the one where you had a graph and you hit the table button and it generated, the table with all of the different ordered pairs. Do you have something built in yet that does go the other way, where if you provided a table, it would generate a graph, or is that something still to come perhaps in the future?
That's a great question. We can kind of do it. And let me show you what I mean by that. So that's something that's, the full functionality there is yet to come, but let me show you what we can do so far, and it's pretty useful. So one of the reasons why you might have a table of data is because you want to import some data into your Math Whiteboard. So for example, we might have a graph here, and it's an empty graph. And from the drop-down menu of the graph, I can select import or edit data. So now I can paste from like an Excel spreadsheet or a CSV file some data points. So I'm just going to type some data points in here. So 1, 2, and 2, 3, and 3, 4. Those are data points. And now we've got our points plotted here. Another way to enter coordinates into the graph area is to just write them on the page. So for example, I could write 1, 2. Or actually, I'm already plotting 1, 2. Let's do 5, 3, and we'll graph that. We can just graph that like that, and now that'll be plotted in the graph area. So something similar or closely related to what you're asking about, and we're continuing to evolve that bit of functionality. So stay tuned again about that.
That's excellent, fantastic. I do know one of the other questions that comes up when it comes to collaborating will be the question on students submitting work or turning things in. And we know this is a continuum. On one end, you've got, easy, no login, no usernames and passwords. And on the other end, you have, these features such as submitting and so forth. And on that scale, we're more with this product on the end of, well, no, there's not an account here. So we have to understand there's no way to say, well, that was Johnny, that was Mary, that was, we are all kind of anonymous. success in this. So do you have any words of wisdom when it comes to having people deal with that sort of thing and needing to submit their work when it's done, and there's not really a submit button, obviously, with this sort of a product?
Yeah, I'm going to give you 3 answers to the question. You get 1 question and 3 answers. That's a pretty good deal. um, so one thing you can do with Math Whiteboard is that you can just clear the page here. I'll show you. So let's say this is my solution that I want to hand in. Pretty simple solution with a graph. You can print these Math Whiteboard pages. So I can just go to the print menu from the browser tab and select print. And then I can print the PDF. And what this will do is it'll create a PDF file that I can then print out. And if I need to submit this to the teacher, I'll have an image of what I created. So you can see that here in the browser preview of the print. Another way to do this is if you are, say this is a collaborative document that you've shared with someone, but you want to just have your own copy that maybe you submit to your teacher. Another way to do that is, and this is kind of a little cheat, but this is perfectly fine. It's allowable within our system. You can start another whiteboard. So I have one whiteboard on the right hand side here, and I have another whiteboard open on the left hand side, 2 different URLs. I can take a copy. I can make a copy of any of these pages. So I can on the right hand side, I'm clicking on this page, I'm hitting Control C, and then on the left hand side, I'm hitting Control V, and then I am pasting that in here. So I've just copied from one Math Whiteboard to another Math Whiteboard on the same computer here, which is pretty cool. And then the third answer to the question is that if you really need that functionality, if you really want your students to be submitting work, which is a pretty important thing, the fluid math system that I was speaking about earlier provides that functionality because it includes all the Math Whiteboard functionality plus the ability to create, hand out, and hand in assessments. And by the way, it also has this other cool functionality where it's got what we call a math answer box, which will test for the correctness of answers, of free-form math answers, which is pretty cool as well.
Well, thank you so much for explaining that, and that's totally understandable. It is really that continuum of, to trade off. If we want the ease of access and no accounts, then we have to be a little creative with how we're then documenting what our students have done. I do see a few more quick questions. I think we can squeeze these in before we run out of time. One was, in general, the question was, what platforms can this be used on? The specific question was asking, can you use this with a pen on a tablet? But in general, Chromebook, Windows, Mac, mobile, what's any limitations on the devices this can be used on?
In general, it works everywhere. So it'll work on Chromebooks and Macs and Windows devices. With regard to phones, sometimes the form factor of the phone can be pretty small. So handwriting math on a phone is sometimes a bit challenging because it's such a small device. But it just runs everywhere. It just runs in a browser. So that'll just run anywhere. That's
fantastic. And I know that you've mentioned already that Math Whiteboard is technically a subset of your larger product. This is the free portion of that. I think that sparked somebody's mind with a question, which was, what about integrations into other learning management, systems, Canvas, Schoology, things like that? Do you guys have an option for that? Is that something you've considered to be able to integrate a tool like this into other platforms?
Yeah, stay tuned on that. There may be some integrations coming soon, so just stay tuned. That's about all I'm going to say.
That is perfectly fine. And I do see we have a few people who have joined a little bit later, so I do want to let them know, hey folks, this is being recorded, since as a live stream. So if you missed some stuff earlier, definitely you can, go back to the link after this is done and you can pick up some of the things earlier. Just wanted to to give you that assurance that this information is available, because I'm seeing some repeat questions showing up, and questions about how can this be free and things like that. And like we said, it truly is a free tool. The company creates other products that are sold. This particular tool is a free tool. Well, I think as I'm looking here, and I'm going to definitely give you any last minute things that you would like to share. We're down to about 4 or 5 minutes. The only thing that I remember that I don't think we discussed here was the ability to, for example, drop a PDF on top of your Math Whiteboard and then annotate on top of that. That could be something folks might be interested to see that, but I also want you to be able to share whatever last minute things you think would be valuable for people.
Yeah, that's a great question, and perhaps saving one of the best features for last. It's a simple feature, but really powerful because it's very practical. So one of the things that math teachers are well known for is having lots and lots of PDF files, possibly organized into folders. And I happen to have a folder open on my page here. It's a folder with about 9 or 10 PDF files in it. Your average algebra teacher might have hundreds of PDF files. I'm going to just open one of these. Let's say we say solving systems of equations. I'll just open that in Acrobat Reader just to take a look at what this looks like. It looks like any other math worksheet. It's a homework assignment or an exit slip. I can take any PDF file and drag and drop it right into Math Whiteboard. And all of a sudden, that PDF file becomes the background for my Math Whiteboard, upon which I can do all of my cool Math Whiteboard stuff, like write math on the page and put graphs on the page, and maybe put solutions on the page also. I can also just annotate the page. So maybe I turn on my draw pen and, okay, we're going to work on this problem. And, it's got several steps here. And down here at the bottom, there's an answer. And then maybe we're going to work on this problem second. And by the way, this could be shared between multiple people. So you could have, the blue user on the left-hand side, they're working on question number 1, while the second user is working on question number 2 and coming up with an answer. And maybe the teacher is watching this in real time as they're annotating it. So what was a static PDF file that we printed out on paper and handed out to our students becomes a live, interactive, dynamic, shared web page that, again, can be shared synchronously in real time with our students. And by the way, this was a multi-page PDF file. So there are 2 pages here. Every page is imported as a separate page in Math Whiteboard. And by the way, this doesn't have to be a math worksheet. You don't have to do all the math stuff. This could be a chemistry worksheet. For the folks who asked about chemistry earlier, you could just drag and drop your chemistry worksheets, your PDF files in here, and annotate them using the drawing tool. So a great question there, yeah, and possibly a really powerful use of this as well.
Right, and so a PDF can serve as a background, and really can other things as well, like PNGs or JPEGs. Can an image file also be used as a background?
Yes, a great question. You can drag in image files. In fact, one of the things that we've seen teachers do and students do is they'll take a picture of their homework and ask the teath a question, say, hey, teacher, I'm working on this homework assignment. I don't know how to answer the question, or I need a problem. And they take a picture with their phone, drag and drop it into Math Whiteboard, and then the teacher can annotate right on top of the picture and share the space with the student in real time. So
well, that is awesome.
It alleviates the problem. Yeah.
Well, Dawn, I want to thank you so much for taking an hour out of your day to share this with us. I want to thank you so much for being so instrumental in the creation of this tool and for the commitment you have to education, to providing this to schools. I want to thank everybody who's been with us live today for, again, taking an hour out of your day, for the great questions, and for those who are watching a recording of this later, thank you as well for taking the time to be a part of this. I did throw the link into the chat for everybody, but again, it's just mathwhiteboard.com where people can access this tool. Any final words or information you would like to share to folks, Don, about how to contact you or the tool, or anything else you would like to give to the group?
Yeah, Eric, thanks again so much for having me. It was a great pleasure and lots of fun. And if any folks want to reach out to me, I'm happy to chat with you. If you have any colleagues or friends that you think would like to see or see a demo of Math Whiteboard, I'm always happy to have a call or a session with folks, a live session, and answer questions. And as Eric mentioned earlier, we're a small ed tech company, so we're always happy when folks can spread the word. So if you really like what you saw and you want to share it with folks, whether it's in your own organization or if you're connected to some professional networks, or if you're on social media, feel free to send out some love about Math Whiteboard. We really appreciate it, so we can spread the word about what we're doing. It would be great. And again, the website is mathwhiteboard.com. The Twitter account is @mathwhiteboard, and I'm Don.
Well, I tell you, if I can, by judging from the comments, I'm pretty sure there's going to be some love being spread based on this. A lot of awesome comments in the chat of people
Awesome.
very, very impressed. So thanks again, everybody. So very much looking forward to seeing all that you guys are going to do with this, because ultimately that's what it's about. It's about making a difference in our kids and helping them to learn and achieve and understand math in ways that they've never been able to before. So this is fantastic. Thank you so much, everybody. Have a great day.
Thanks, Eric.